Okay, here's another kinetics problem. We've got this chemical reaction, and we're asked to write a rate expression for each reactant and product. I like to remind myself that reactants go away or decrease in concentration, so I put a little minus sign above those two reactants. And then I like to remind myself that the concentration of products forms or increases in concentration, so I like to put a little plus above that product here. And so the rate is going to be the change in concentration over change in time, but we want to pay attention to the sign that we've created here, as well as the coefficients. There's a coefficient of 2, there's a coefficient of 1 not shown, and there's a coefficient of 3 here. So we can write the rate for this reaction. This is equal to minus the change in concentration of A over 2 times the concentration of T. So we're using a minus sign because this is a reactant, and we're using the coefficient in the denominator here. Same thing for B. It's equal to minus, because it's a reactant, and we have change in concentration of B over 1 times the concentration of time, or just concentration, or just change in time, rather. And then we have change in C over 3 times the change in time. Okay, there's no minus sign here because this is a product. Okay, so this is the answer for part A, change in concentration over change in time. Pay attention to the minus signs for reactants and the positive for the products. Use the coefficients in each case in the denominator of the expression. Now for part B, it can be kind of confusing keeping track of the signs. We could plug things into here and think about what is the change in concentration over time, but it kind of gets confusing solving for things. So I recommend just using stoichiometry. So the change in concentration of A over the change in time, okay, just change in time, not 2 times, change in time, right, is 0.100 molar per second, but it's decreasing, okay, and it makes sense because we put a minus sign up here to remind ourselves that concentration decreases. So when we calculate the change in concentration of B over time, it should be some negative quantity. And when we calculate the change in concentration of C over time, it should be some positive quantity. Now what I recommend is just converting from A to B and A to C using the coefficients in the balanced chemical equation. Don't worry about these expression in part A. So basically we have minus 0.100 molarity of A per liter, right, per second. And we just want to convert from A to B here. So if we look at the balanced chemical equation, we can see that 1 mole of B reacts with 2 moles of A. Okay, and I would actually just ignore the sign here for now and just put it in at the end. So what we have here is half of that, so that's 0.0500 moles of B per liter per second, or just 0.0500 molarity per second if we're talking about B. Now since we're talking about a reactant, there should be a decrease in concentration. They say right here decreasing, so we can just put a negative sign here. Okay, so that's going to be the change in concentration of B with respect to time, seconds. We do the same thing for C. So we have our concentration, moles of A per liter per second. And then we have C, so we have 3 moles of C forming for every 2 moles of A reacting. Okay, and go ahead and work that out. And don't worry about the sign right now, we'll deal with that afterwards. We get a value of 0.15. add a 0 here from a calculator display to maintain 3 decimal places, 3 sig figs. And that's moles of C per liter per second. And moles per liter is just molarity. So that's 0.150 molarity per second if we're talking about C. And what should the sign be on this? It should just be a positive sign. So we'll just not indicate anything there. So this is the amount of C that forms per second. This should actually be increasing. Okay, so here are your two values here.